In the first two examples you saw in this particular lesson, you are given circumstances where you had the number of elements that were in a region that was specifically single region. It wasn't a combination of two or more regions. Either it was the region where all three circles overlapped, or it was a region that was defined by only meeting one of the three characteristics. Well, what happens if you have a circumstance where you're not given either one of those, which makes it even more challenging? So we're going to go through an example here for the sole purpose that this is the kind of situation that you're going to have on your project, and therefore this would kind of give you a good way of attacking that project and being able to answer the question correctly for that project. Helena is a financial consultant and has customers that own stocks, bonds, and/or mutual funds. In a survey conducted by Helena, it was revealed that of her 400 clients, 300 owned stocks, 180 owned bonds, 160 owned mutual funds, 110 owned both stocks and bonds, 120 owned both stocks and mutual funds, and 90 owned both bonds and mutual funds. How many of Helena's clients own stocks, bonds, and mutual funds? So this is definitely a different case, and it's a much more challenging problem because if you notice, the the one piece of information that we usually like to see, which would be, the number of our customers that own all three types of packages here, or stocks, bonds, and mutual funds, is actually what we're looking for here. So we're not given the piece of information that we usually make use of to complete a Venn diagram. So, and that's the way we would normally start tackling this. We would try to say, well, let's try to do a Venn diagram. The only piece of information I have in this Venn diagram is that in order to be Helena's customer, you have to own stocks, bonds, and/or mutual funds. You have to own at least one of these things. So we have 400 clients. None of them are out here, which means that this total area that's within here should be 400. But that's really all I know. I mean, I could kind of attack it like I did in the previous problem where I said, okay, let's come up with some letters here. But if you notice, none of the information that I'm given defines one of these variable regions specifically. It's always going to be a combination of two, three, or even four of them that they're giving me the information on. And so I just don't have enough information, outright so far to tackle it that way. I mean, if I want to start making some equations, I mean, I can start saying that t plus u plus v plus w is 300, w plus v plus y plus z is 180, and I have all these equations with these variables in it, and I have 7 variables. I would need to come up with basically 7 equations and try to work my way through them using methods that you may have learned when you were doing um, systems of equations in your algebra days. But that would be very lengthy and time consuming. And the method that I'm going to show you is a little bit better, and it's kind of related to something we've already done. I mean, I could come up with a 7th equation because I would need that 7th equation because since I have 7 variables, and the fact that I know that her 400 clients, have to have at least one of these things, then I know that all of these 7 of these variables together total should be 400. And so I could come up with some information, but in each one of these cases that I've given down here, there's always like at least 2 of the variables missing, so I can't just say that one variable is going to equal this amount. I would have combinations of them. So, ultimately I am looking for what V is, but instead of thinking of it as V in this respect, I'm going to think of that as I'm looking for the number of those who own stocks and bonds and mutual funds. And I'm going to also look at the fact that I'm going to, instead of putting these in terms of just the variables, although I'm going to make use of them in a moment, you'll see how I do it, I'm going to keep them more along the lines of their, notation of what they're telling me. When I have 300 stocks, it's telling me that I know what N of S is. For 180, I know what N of B is. 160, I know what N of M is, and so forth and so on. So I'm going to use this, which is the kind of notation we've used. And up to this point, we've had a formula for the number of elements in a union, which is ultimately I have involving here. But that was a union of two sets. If I'm looking for the number that are in the union of A and the union of A and B, then I would do the number in set A plus the number of set B minus the number that are in both sets. And we talked about that before, and that's because that the region is counted twice when I just add NA and NB. Is there a similar rule for relationship between three sets? Well, this is where we're going to make use of our Venn diagram as far as this goes, because I can certainly say, okay, well, based off the information that I have, I know that the number in the union of S, B, and M would be all 7 of these variables added together. So I have that piece of information. I was given information about these, the numbers in these various sets or combinations of sets. And I know I'm looking for a formula that's relating the intersection of the three sets, because that's what I'm ultimately looking for, and the union of the three sets along with these values that are up here. So let's take a look at something. I'm trying to find something that equals the same as these 7 variables added together. Well, if I just do the number in set S plus the number in set B plus the number in set M, I would have T plus U plus V plus W, because that's what S is, Z plus W plus V plus Y, because that's what B is, and I would have X plus U plus V plus Y, which is what M is. If I add these together, I would have T plus X plus Z plus 2 U's plus 2 W's plus 2 Y's plus 3 V's. That basically is telling me that these regions W, U, and Y are being counted twice when I just add these three sets together. And I expect that because of the overlap. And because this is in all 3 of these circles, this gets counted 3 times when I add those together. That's not the same thing as what I have up here. I want to try to make this equal the same thing as this. I have part of it. I mean, I have the T, I have the X, I have the Z. I have too many of everything else. So let's look at, what if I start taking these combinations where I have 2 of these known to be? So I do the minus the number of S and B plus the number of S and M plus the number of B and M, which would be me subtracting X, W plus V plus U plus V plus Y plus V. And if I carry through that subtraction, what I'm going to end up with is T plus X plus Z plus U plus W plus Y, because each one of these, this W got subtracted from one of these, making it 1 W. This U got subtracted from these 2 U's, making it 1 U. This Y got subtracted from 2Y to make it a single Y. I had 3 V's here, and I have 3 V's in here that made the V's go away. But notice, this is almost the same thing as this. I'm just short V. I need to find a way of getting V in there. Well, you have to remember, V represented the number that were in S and B and M. If I added that to this sum, I would get my plus V here and here, which would make this and this expression here the same. So these are now equal statements. This statement up here and this statement down here, which means that I now have a formula for 3 sets. So if I want to find the number in the union of 3 sets, I would do the number in each set individually added together, subtract away the number that are in the intersections of 2 of those sets all added together, and then I would add back the number that are in all 3 sections or sets at the same time. What does that mean for us in this problem? Now what I could do is I could take this information, know I'm looking for this, and set it up. I know that the number that are in the union of the 3 sets equals the number in set S plus number in set B plus the number in set M minus the number in set S and B plus the number that's in S and M plus the number that are B and M. That sum being subtracted, and then I'm going to add the number that are in all three sets. Well, this information I was given in the problem gives me everything up to this one over here. So if I know all these other pieces of information, I can figure out what this is. So through some substitution, I know this is 400 because I know her 400 clients, have to be, this. They have to have one or the other, or, combinations of two or three of them. This was 300, 180, and 160 from this information. This was 110, 120, and 90 from these pieces of information. And I'm looking for this. That's the only unknown I have. So 400 is going to equal, well, these three added together is 640. These three added together is 320, hence the 640 minus 320 plus this, which means that the number that are in all three sets plus 320 equals 400. And then when I subtract 320 from both sides, I get that number is in fact 80. So there is a formula that'll let you come up with this type of situation if you need to figure out where all three, or the number that's in all three sets at the same time. But you have to make sure you have all this other information to actually do it. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.